So, the history of the web, part one. I don't know how many parts there'll be. I thought this could be part one, and it's the first 20 years, sort of. You can, of course, with all histories, go way back to the beginnings of time to see where things have come from, and they don't stop. They're always evolving. The way you look at the past evolves, and also the impact these things have in the future. Of course, we can't yet see. The first 20 years on August the 6th, 1991, Tim put the first website up, basically, Tim Berners-Lee. So that's sort of but there are lots of beginnings to the web people talk about. The BBC always celebrate August the 6th. We always get rung up because it's summer quiet time for interviews about, let's celebrate the birthday of the web. But anyway, so I'm going to look to the future as well, but I'm going to tell you my history of the web. You know, everyone has their own. I've lived this world, and so I'm going to tell you my perspective. This is not, we were talking about this at lunch, this is not an authoritative historian's perspective on how the web evolved. It's my perspective. If Tim was standing here, he'd give you his perspective. If Robert Caillie was standing here, his co-inventor, everybody would give their own perspective. This is my perspective. And I started in the hypertext, as Uta said. I don't know why I was teaching Prolog and logic programming, and I suddenly saw this somewhere, these multimedia, these video discs. We didn't even talk about digital video or multimedia in those days. This was, before the web, before digital video, before CDs even. And I saw these video discs, and I began to see the potential for education, actually. That's where I got interested, was computers and video discs. And then I heard about this thing called hypermedia. And I read this paper, As We May Think, by Vannevar Bush. How many, hands up, how many of you have read that? Not enough, right? Your homework is to find that on the web and read it. It's not very long, but it's very profound, and we still can't do the things that he predicted. He was the scientific advisor to Roosevelt at the end of the Second World War, and part of the Manhattan Project, and foresaw this explosion of information that scientists would not be able to know everything about their subjects. That they would have to know about other subjects, and they would have to learn as they went through their careers about their own subject. And he had this idea that if you look at the illustration to the paper that was published in the Atlantic Monthly, it's a man with a camera on his head. This is 1945, and Bush's idea was that you would take a picture of everything you read, and a machine would store that picture and help you find, this would be pictures of documents and so on, and would help you find them again in the future and create trails, paths through that information. And so he was effectively talking about something like the web, but before computers, it was microfiche he was designing for. And his machine was called Memex, or the memory extender. And it was all about helping our memories, basically, extending them, using machines to extend our memories. And As We May Think was the idea that actually, I've had conversations with Uta about this, we don't understand how the brain stores its memories, but maybe there are things we could learn from the way we think in order to help design the machine. So there was a two-way process. Fascinating, read it. He never wrote again, really, about the subject. He was, historians can tell you more about him. But actually, the people that really inspired me, this was all 1987. I found this all out in 1987. It's a big year for me, and for hypertext, actually. So Ted Nelson, on the top left, invented the terms hypertext and hypermedia in the 1960s. And hypertext is the idea of linking between documents using a computer to help you do that, point from one document to another. He invented this term in the 1960s, right? Some of you will remember computers in the 1960s. There were very few of them. They were very big and very difficult to program. And he foresaw the whole internet cafes using screen to point to things and link. And he also, at the same time, talked about hypermedia, which was linking different media. And in the 1960s, the idea of having a picture or a piece of film on a computer was just science fiction, really science fiction. He's an amazing man, one of those visionaries that never quite achieves what he wants to achieve because he's always about 40 years ahead of everybody else. He came up with the term everything is deeply intertwined, and of course the web, if we didn't know that already, has certainly shown us that. And then, how many of you have heard of Doug Engelbart? Hands up. Oh dear. Well, everybody should really... He isn't... I wouldn't expect any more than that. He invented the mouse. You've all heard computer mouse. You've all used one, or certainly know what they are. That, if he had a patent on it and charged a cent for every mouse that was sold, he'd be a multi-billionaire. He didn't, like a lot of computer pioneers, not all. Bill Gates and people are different, but they're entrepreneurs in the sense of making money. But Doug largely gave his ideas away. He invented the mouse, he invented the whole concept of Windows, and he gave the first live demonstration in 1967 over a network in San Francisco of pointing to a screen, clicking, using his mouse, which was a cooled mouse, and going to another screen. Right? Amazing. So these guys are the real fathers or grandfathers of the web. Doug's system was he talked about augmenting the human. Augment, and he was talking about augmenting the human intellect. The same idea that this is extending what our brains can do using machines to support what we do very well. So, what do India, the old Mountbatten of Burma, the University of Southampton, and my research career have in common? In 1987, Mountbatten's archive came to Southampton. Mountbatten, he was killed by the IRA in the 70s, and his family home is Broadlands, which is just north of Southampton. And Southampton University is the custodian of his archive. And here's me in 1987 with that archive. Now, there are people that say that's my shoe collection. I say that joke every time. It always gets a bit of a laugh. But that was multimedia in 1987, in the sense that this was a multimedia archive. You can see me there looking at one of the photographs. The only way you could look at the archive in those days was to go to the library in Southampton. And, I was given very special permission to be able to hold that photograph. The vision in those days then was to digitise, which I'm not sure we even used that term in those days, but to put all this on a computer and to create links between the documents. So I could maybe show... so that people could see the archive without going to the library, and that we could link between, the record of a meeting at Viceroy House in Delhi to pictures of that meeting, right, to make inferences about what was happening. And I wanted to create different links for different people, so that children looking in the archive would want to know who Gandhi was, or who Mountbatten was, But historians would be wanting to look much deeper as to why things were happening, and so it was really different links for different people, and so that was the beginning really of my quest to build a system that enabled people to get the information they wanted when they wanted it, and to link it all together. This was about 250,000 documents, 50,000 photos. We never completed digitising it, and what actually stopped that was the copyright issues, actually, and the cost was another big one for doing the digitisation. This is 1987. Never thought that, in 20 years' time, we'd be dealing with a corpus of information that had billions of documents, and all these ideas we'd be applying on a network to link all these documents together in ways that in those days you would never think could possibly, what we were doing could scale to that size. And of course, we're now in a world where the information is created digitally. In 87, you by definition were pre-digital, and so everything had to be digitised. So we've shifted so much. Now, the other thing about 1987 was this was the year, it was the first ACM Hypertext Conference. The ACM is the Association of Computing Machinery, the US-based computer society that I became president of. Never dreamt in those days I'd ever be the president of the ACM. But they had their first hypertext conference, And Apple, very new company in those days, released a product called HyperCard. They changed the name just before they released it. I can't remember what it was, something card, and they'd cottoned on to this hypertext idea and decided that sounded cool. And HyperCard was stacks of cards, software to stacks of cards that you could program, very simple programming language, and you could link from one card to another. So you had a very simple hypermedia system. And it was a bit of a craze for a while, used a lot in schools, very pioneering time. But this was like a seed change in the world was ready, the internet was there. Right? I'm not talking about the history of the internet per se, that's the network of computers underneath the web. That was there, ready to go. We were hungry to share information on this new mechanism. This was a slide from Microcosm. Using the Mountbatten application, we digitised I think, the whole of the India, the 2 years in India. That was a nice self-contained application. I must speed up a bit, I'm still in 1987. And I won't go into the details, but basically I was trying then to create associative links between information, not just pointers, but to define semantic relationships. Why was that link created? We kept our links in separate databases. Why I'm telling you this, I'm not just bragging about what we did, because actually the web won, we didn't. But I'll come back to this later about links between objects that you store separate from the objects. And this was our system. We had viewers, and again, I won't go into this. It's not appropriate, and I haven't got the time to go into the detail of the system. It was very clever, did lovely things, and. But the key thing is our links were triples. And so we said it wasn't just a pointer to another document, it was here's the source, there's the destination, and this is why these two things are linked together. And the other thing was, when you took a big corpus of information like the Mountbatten archive, you'd think about how are you going to make links in all that? It just doesn't seem, how are you going to do that? So what we started by doing was to use I said some simple natural language processing, I suppose, to create some metadata, or maybe by hand, I really can't remember. And then we linked them on the metadata, and a linked corpus sort of fell out of that using our system. We were all very excited about this. So we went to Paris, 1990, the European Conference on Hypertext. And a young chap called Tim Berners-Lee was there. And you can see this is, on the... you can see the contents of the participant list for this conference on the web. So we were all there, and this is the photographic evidence. On the right is Tim saying he didn't call it the web. It wasn't called the World Wide Web then, but he'd begun to design the system. And he was probably going, these are my links, they're bigger than yours. My colleague Andrew Fountain, my PhD student Ian Heath with the grey jacket on. Behind him is Robert Caillou, who was with Tim at CERN at the time, developing the web. Tim was the techie. Robert was one of the powers behind the throne, whose name has got lost a lot in history, but he had a lot to do with it at the time. And then the link to the other photo is Ian's leather jacket and me. So yeah, that proves to Tim that this is where we met. So we talked about microcosm. He talked about the web. I've been friends with Tim ever since. But it was one of those conversations where we weren't listening to him. We were so excited about our system. He was so excited about his system. We did actually then, we went out to CERN a lot and started to build web browsers into our system. But I didn't get I didn't get Tim's vision then. A few years later I did. So I don't have any photographs from this, but this was a seminal event. This was the third ACM Hypertext Conference, so we alternated Europe and America. This was back in Texas in 91. And this is the first, by this time, this was December 91, and Tim and Robert had called it the World Wide Web then. And I remember thinking how pretentious to call it the World Wide Web. It's like the World Series of baseball. And this was like when all conferences, this was a peer-reviewed conference, and this was the conference that famously rejected Tim's paper about the web. And as he will say, well, it wasn't the greatest of papers, but it was the greatest of ideas. So And they rejected our paper on microcosm, our second one. And so what do you do if your paper gets rejected? You submit a poster or a demo. So Tim and Robert were out there with a demo of the World Wide Web. Except there was no, of course, we were in a hotel in San Antonio, no internet in those days at all. I think in his book, Weaving the Web, Tim talks about having to pay for the phone line to do the demo. So I think a lot of the time it was running in simulation mode. We were demoing microcosm, Tim was demoing the web. But the main thing I remember about this event was it was quite a warm evening, December evening in San Antonio, and in the courtyard outside the demo room was a tequila fountain. And everybody was outside drinking free margaritas, right? So nobody was inside. Nobody. This is the first demo of the World Wide Web in America. So we were all wandering, and I remember we were wandering around looking at each other's demos, and I remember looking over Tim's shoulder with some of the hypertext people from the UK and thinking, well, there's nothing very clever about this system. He's just got pointing links, and the links just point to documents, and they're embedded in the documents, and this isn't going to go very far. So here he is. How wrong can you get? This in the middle here is a famous piece of history. This is the document Tim wrote in March. You can't quite see it. March 1989. To get permission from his boss, Mike Sendell at CERN, to work on this thing. He called it then a proposal for information management. It wasn't called the web, but this is effectively his design for the web. And Mike wrote at the top there, vague but exciting. And basically gave Tim then permission, although this wasn't really part of his job description at CERN. He was a systems guy at CERN, but it gave him permission to develop this system that became the world's biggest information architecture. And developed into this thing that's still growing today. And the lessons that I learned from this experience, and that I think really made the web the thing that took off, when there were lots of other hypertext systems around at the time. There were some commercial ones, mainly being used on the PCs, Windows PCs, or the Macintoshes in those days. The thing that Tim got more than anybody else, there was another system called Hyperchi that got it, but they were a closed system. What Tim got was that the network was everything. His thesis, which I see now totally, but I didn't see at the time, was that this hypertext thing, which we all thought was so clever, would only work if everybody used it. Right? It's either all or nothing. Either everybody would use it or nobody would. And actually, what's happened with the web, with the scale-free, the power laws it follows, and the fact that the way you've got the attractors in there. So, I'll say this now in case I forget to say it later. Although the web is open, universal, free, anybody can develop on it. There's only one shop. There's only one search engine. There's only one social network. There are all comers to this, but actually, what's the search engine everyone uses? What? And can you remember there are others that have been contenders for that. What's the shop? Amazon, right? What's the social network? You wouldn't say MySpace today, would you? And so it's this business of you've got to be where everybody else is, or there's no point in being there. Right? That's how this thing works. Another thing that really was important, and the hypertext community, a bit like the artificial intelligence community, was worried so much about building systems that had errors in them. And error 404 was very important in the web because, to paraphrase, you have to let the links fail to make it scale. We as human beings are not perfect about the way we manage our information. We forget to tell the system we're moving a file. We forget to delete things. We leave dangly links all over the place, move things around. Scruffy works. I can remember reading hypertext papers that said if you build a hypertext system that has dangling links or links that fail, are dead, people won't use it. And they were doing the experiments like we were on standalone, PCs not connected to the network, with very small amounts of information and small hypertext sets and a small number of people. And so, in retrospect, that was madness. To make it scale and be successful, you had to let the links fail. Scruffy works. The AI community has learnt that over and over again. And the other thing is democracy rules. Tim's real legacy is that he gave it away. And this was quite deliberate on his part. He realised, or his hypothesis was, that if it wasn't open, free and universal, then it wouldn't get used. It has to be the same everywhere. And it's not that... It's the fact that the protocols that are there to let you access the internet are the same all around the world. That's what the web is, a set of protocols and standards, really. What we put on the content is us. The web grows because we put content on it, not because it was designed... Well, it was designed to grow, sort of, but it's not the engineering that makes it grow, it's us that makes it grow because we put things onto it. But the protocols are the same everywhere. So when I go to China, I can, you can just use the web there because because it's all. I can port my system there. It's the same thing. It's the same web you're using. Content's different, the culture's different, the language is different, but it's the same technical web, and that's so important. And that's really important going forward because when the issue of net neutrality is very important. If you start fragmenting the web, fragmenting the internet, charging more for bits of it because you want to be able to use it faster. If you fragment it, it could kill it. And there's all sorts of. I'll come back to this at the end. How we understand what could kill it and what couldn't, and what's so important about these rules. But open and free. The argument was again, everybody needs to use it or nobody will. So you make it open. Now, if Tim had been an entrepreneur like Bill Gates, we would have had a very different web. It's interesting to think about what it would have been if you would charge per link, or you had to download some software that you paid for to use the web. It would be a very different world. We might still have a web, but it would be different. And it's an interesting... We often ask our students to think about what it might have been. What are other possible webs? But we can't run the experiment again. Well, maybe at some point, maybe it will die and we'll have to, another one will emerge. We don't know that, but just as it stands, you can't sort of start another one and see what happens. It's very difficult to simulate. But, so on the face of it, Tim's hypothesis was the right one. But the fight to keep it open and free is why he set up W3C. Now, I was saying at lunch that, in the early 90s, I'll come back to that in a minute when I put the graph up. I just want to make the point here that the web is a very simple hypertext system, and some of the clever stuff got lost, but we're rebuilding that with the semantic web. And so I've got here the missing link, search engines fill the gap. So I will say, when the web started, there was one website, Tim's. Right? It's not a very exciting web to be on. And then as it grew, well, by the time you got 100 or 1,000 websites, you had to have ways of finding stuff on the web. And if you can remember back to those days, in the early search engines, they did full-text retrieval to find documents, but also they published lists of new websites. They were directories to websites. And you sort of found out things because you heard about them. Someone told you, or you read on Alta Vista there was a new website. But once it gets over a certain size, you can't do that. And so these guys came along with their algorithm for finding things on the web more accurately than anybody else, using the web to do it. So we couldn't have built Google before the web. It would have been hard to design it before the web, because until the web starts to grow, we didn't know what we needed to find things in it. And Brin and Page came up with the algorithm. Basically, they said, well, we're going to use full-text retrieval. We'll search every document on the web every day. Imagine, we take that for granted. That's what Google does. Almost. It caches things and it does clever stuff. But effectively, And they said, and we'll also find the best document, not just because it's got the most number of words in that are like your search term, but because other people are pointing to it. So it's all about what I'm going to take the most popular document because it's got the most links pointing to it, and those documents have got the most links pointing to them. So if your document is pointed to by the BBC or something like that, you'll get high up in Google. There's all those tricks you play to get high up in Google. And, do you remember when Google came out? And it was like magic. It sort of worked. And it didn't have any advertising on it. And then they spent years trying to find a business model. And now look at them. The James Bond villains of the future. Potentially, they know everything about us. Anyway, so here's a graph that one of my PhD students keeps up to date for me. And I could talk about this graph forever. This is what, if you're going to do anything on the web and you want to be successful, the development of your product has got to look like this. At some point, it has to take off. And what we're interested in the world of understanding the web is what are the tipping points that make it happen. So I forgot to bring my pointer, but right at the beginning, there was Tim's website, and then others went up. Can you remember the first website you saw? Apart from Tim's, I remember the dinosaurs in Hawaii. That was the first one I saw. I think that somebody said, have you seen this site about dinosaurs in Hawaii? I can just click and go to it on the internet. That's clever. And you can see, of course, on the scale of this graph that it's very slow to start because nobody's using it. There's no reason to be on it. And our universities were at the beginning of all this. Of course, it was the physics community because Tim was there at CERN. Building this so the physics community could share their documents about their experiments. And research labs in universities started to, because we had the internet, started to use it, and we very quickly put our course notes on. By 93, I think, at Southampton, and many other universities had. The other thing I haven't mentioned, of course, is the browser. Mosaic was the browser built by Mark Andreessen at NCSA in Chicago, just outside Chicago. And Tim's browser for the web was both a reader and an editor. Tim doesn't get everything right. Most things he gets right, but this was he didn't think people would use the web if they couldn't write to it as well as read it, because he was so anxious to write, and all his colleagues were, and put things on it, and he thought people would want to write to it as well as read it. And the Mosaic guys came along and said, here's a very simple browser for the web. This will give you, this is a view on a document. So if you click on this, you go to another document. It's as easy as that. Download it from here for free. And that really was the tipping point for the web. It enabled it to take off outside the research labs. That was quickly commercialised to Netscape Navigator, and then you've got the apocryphal story of Bill Gates, who was saying, I've got Windows and I've got every machine's got my operating system on, what do I care about the network? Famously changing his mind overnight, apocryphally, and building Internet Explorer into his operating system, wiped Netscape Navigator off the map. Started the dot-com bubble because Amazon's emerging, let's sell stuff online. But if you look at, we all know the story of the boom and bust, but it was inevitable. If you look at, and we've had many since actually, this was the big one, people lost a lot of money, so it's not a happy story. But if you look at what's happening, Google is beginning to emerge. You can see the graph start to take off here as the web becomes usable and more used. And then the technology, broadband wasn't introduced until the turn of the century, and very few people had computers at home. And if you had a computer at home, if you remember how awful it was to try and get on the web through a modem, and that dreadful noise you got and listened to forever, and then it timed out, and how long it took to download a picture of nobody. Why was anybody going to buy anything on the internet? So things were way overvalued. And we've been through several of these cycles, but this was the big one at the beginning. And I can remember reading it was either the New York Times or the Washington Post or somewhere, an American, well-respected paper in America, a journalist writing in the early part of the 2002, whatever, saying, that's the end of shopping on the internet. And here we are, this Christmas, they're predicting huge growth on online shopping, and it's taken over our world because of the development of the technology. The world wasn't ready for what was being sold. It's a bit like people who were trying to sell books in the 16th century to people who couldn't read. It's that same sort of chicken and egg situation. And the other thing, we now just take all this for granted, by the way. I mean, people just use it because it's there and it happens, and I don't know who owns the web or what how it's run or anything. I just use it, and I've got my mobile phone, and all the things that have come along since. And so there are three sort of phases here. As the technology evolved, the web did become read-write. And the interesting thing is that the applications lag behind these developments. So as it became read-write, people discovered they could write to the web, diaries, I'll call them weblogs or blogs. And as that then the technologists come along and say, people want to do this, let's write an application so anyone can write a blog. And then it sort of takes off and they all get linked together, and we've got the blogosphere. And all these things have developed in that sort of way. Now everything's on our mobile phones. And we've got because we can write to the web, the social networks have developed from that. We could write applications. You didn't have to be a programmer to be able to put your photos up on the web. And the amazing thing, the social phenomenon is, but why would we not have predicted it? Because actually, what we do is communicate. It's what makes the worst thing you can do to a human being is put them in solitary confinement. We love communicating. And I think we underestimated totally what people would do with this stuff. We predicted virtual communities. Did we predict the massive impact on society that the social networking phenomenon, or that society would create this phenomenon that means that so many people now live their lives in these virtual environments? And so it goes on. Right? This is not the end of the story. So I could tell lots of stories about that, but this is the first. I come back from China, and my students out there did produce these sorts of things while we were there. And this is, I've always told the growth of the web from my perspective in the West. It's a very different story in China, but the curves are sort of the same. The names are different. They started with a bulletin board, and of course their government, their culture means that the social networking didn't take off that quickly. And Baidu is their search engine. And I've got some pictures of this later. They've just started with microblogging has taken off. They weren't allowed, they couldn't use Twitter, but Weibo is their microblog, and it has taken off phenomenally in China just in the last year. That 80% of the population who are on the internet use that now in China, and it's only been out there for a year. Just amazing. So I've started to this is just I don't have this all yet, but I'm trying to build a picture of what it's been like in a completely different culture. But I haven't got much time to talk about that. Gosh, I haven't got much time at all. So we're in this space of networking, social networking, and a world where we put our photos and our videos and our lives up on the web. Wikipedia, who would have predicted the phenomenon that is Wikipedia? And the rules and governance that has, but basically this is written by the people for the people. It's very accurate because it gets corrected. There are problems with the problem pages, but we can't imagine life without it now. It's so young, it's hardly been around 10 years, and yet it could disappear tomorrow if we stop writing to it. And there's all sorts of reasons why people might stop writing to it. And if it's taken over by a commercial company at some point, who knows? So this is the Chinese version. They now have their own Wikipedia as part of Baidu. I was looking at that. And again, but they have, be careful how I say this, but of course they're not, Wikipedia didn't take off in China because it was very controlled about what they were allowed to write. And now it's taken off big time as part of Baidu. And Baidu has an agreement with the Chinese government, and they employ thousands of people to check what people are writing. But it's free enough in China for it to have taken off. And of course Google wouldn't do that agreement, which is why Google doesn't really exist in China, does in Hong Kong. But they do have their Chinese version of Wikipedia now. And here's the Twitter curve. the amazing thing, this is it's a bit old now, finishes in '09, but so the red line is the takeoff of Twitter, which started, of course, as simple text messages on mobile phones. And the green line is the development of the smartphone, the 3G phone. And again, to me, in my mind, Twitter, people thought it was about telling you what you had for breakfast, but actually it's become a profoundly useful tool for saving lives and communicating, and such a fun thing to do. And you can see I've put there's Stephen Fry famously tweeted from the lift in July 2008 that he was stuck in a lift. And I asked him, when I met him here actually, I assume you were tweeting from an iPhone. You weren't trying to tweet from your computer. He said, yeah, I had just bought my iPhone. I was stuck in a lift, so I tweeted. So that was, that technology enabled that application to hugely take off. I put my colleague Nigel Shadbot on there just because he's an early adopter. I didn't start Twitter till up here. And you can see some of the other things that happened on either side of the Atlantic. And as I said, Weibo they've got the same agreement with the Chinese government. They have hundreds of people that are monitoring what goes up, but the Chinese have become the greatest microbloggers since all time. And there's still millions and millions and millions of Chinese people to go on the internet, so there's going to be a lot of Chinese on the internet soon. So I've got about 10 minutes left. So where we're going now, it was always part of Tim's original vision, and he talks about it in Weaving the Web. The web wouldn't just be a web of documents, and the social networks came out of that. It would be a web of linked data. So if you think of the web as our global document management system, or information retrieval system, information management system, document management system, it's going to become the world's database. So imagine, you're used to having an Access database, or your company has a database, or that you used to using. But imagine one big global database that you could do queries on and get answers back. That's the vision of the semantic web, really, in a nutshell. And if you just let your mind get carried away with that, that's a very powerful vision. But it's harder to achieve than the document web because of the semantic stuff. If you put a piece of data out there, if you put the number 42 out, that could be a date, an age, the answer to life, the universe, and everything. As in database, you have to say what that data is about. So you have to give it a context. So you have to get into these difficult things called vocabularies and ontologies. But they don't have to be difficult. This was in the 99 and early 2000s, Tim published with Jim Hendler this technology graph and said, this is what we need to do to achieve the semantic web. We need structured documents. We need to be able to describe our data as a resource description framework. It's effectively schema-free data, and you can describe schema as RDF schema within that. Schema-less data, anyway, it doesn't matter. You're not a computer scientist, so I won't. But this is my point where RDF are triples. It's subject, predicate, object. And this is, to me, this is my world coming back again. The links we had in microcosm were triples. And this actually, I haven't got time to really go into it here, but we're really getting back to the power of hypertext, which we lost a bit with the web, enabled to really link things at a very, very fine grain. But once, as I said, you have to describe your data using common vocabularies. And then when you're there, if you're going to actually let machines, and the thing about the data world is that machines can do things with data, they can munge data and come up with answers in ways we can't. Whereas machines are very bad at reading documents. We have to put a lot of effort into helping a machine read a document. But once you're in the world of data, you can, and the machines are munging away to find the answers for you. If you get an answer out of this world, you need to know the provenance of it. You need to be able to trust where that data's come from. So the whole idea of proof and trust is very important in the semantic web. I've got to speed up a bit to get to my final point, so I'll whiz through this bit. It's very simple. It doesn't have to be complicated. That's what that paper says. And this is how the linked data world has grown in this is 2007, the amount of linked data that was out there. 2008, 2009, 2010 and 2011 just looks more of that. lots of worlds, entertainment, publishing, science, huge amount of science data, of course. All, geo names, drug companies, all beginning to use this technology to share data. This is Tim's road to start. I won't go through this, but basically the key thing is, the most important thing is to get people to put the data out there, but you'll make it work most effectively if you're linking data sets together, and that's where you'll get information that you wouldn't have known before. You have to, it doesn't matter. So tipping points, the first web was driven very much by the world of commerce. The commercial sector picked it up first. This web is being driven by the public sector, and you may have heard about this week. The governments on both sides of the Atlantic and around the world, largely Tim and Nigel Chabot in this country, and Jim Henner and others in the US, and have this idea of putting government data out as open data, as hopefully linked data, for all sorts of reasons like transparency and efficiency. And this is a real driving force in getting the linked data cloud emerging and being used. So there's a lot of Australia there, New Zealand, and all sorts of governments around the world putting their data out. Cities are doing it. London's one of the big examples. These are some of the reasons why the governments are doing it. But it's all about, for us, it's that we're getting the data out there. This thing's becoming usable. We can build applications around it. So for governments, it's transparency, efficiency, improved public services, so on. And now the government this week announced a big open data initiative to build on this. You can build applications. So one famous example, when the ASBOs here, I don't have to explain what an ASBO is, antisocial behaviour order. One of the first sets of data that went out is where the ASBOs were, and within 24 hours somebody had written an ASBarometer for a mobile phone so that you could see where the worst places were for ASBOs in the world. You can find dentists, you can get tube information, all that on these things. Lots of stuff about spendings going out. This is going to change the way we interact with our governments and our public services. I've not left enough time to talk in detail. Crime data went out, a bit controversially, but it's up there. This is the statement that went out this week about the investment that's going into this. As a university, we've put our data out, and I haven't got time, but things like finding buses is where you can stand there with your mobile phone and look on the phone app. We've got the link from the bus data from the local Southampton bus company, and you can see when your next bus is going to arrive on your mobile phone using this technology. The catering service use it. You can see where you can go and get a coffee while you're waiting for your bus. So what time the bar's open. These are applications the students have written using the data. And when I went to Tsinghua in China this week, they've put up their data, copying our ontology and our way of doing it. I want if all the universities around the world did this, we could put all our courses up and so on, link it all together. We'd have the most amazing resources. So I'm at the final point now. A few things to flick through, but the real thing about this is what's next. I've tried to sort of show how it's evolved and tried to show that actually we create the web, we put the content up there, and when the documents and the data go out, people build the applications. Now it's all on mobile phones to let other people use it. And our hypothesis was that it isn't just the technology, it's what people do with it. And it isn't just social science, because the technology is hugely important. And so we came up with this new idea. Well, it's not a new idea, we just gave it a name, which there are two things we don't like about the name web science. One is web and the other is science, because they're a bit misleading. Social scientists think this is very techy, and computer scientists think, well, this is just networks. Anyway, but we persevered, and so it's really about understanding the web as a phenomena, as a socio-technical system, and as a new branch of science, very interdisciplinary. We launched this is me and Tim and Nigel and a guy called Danny Weitzner at MIT in 2006, and we developed the Web Science Trust in 2009. But that doesn't matter. It's just about getting the ideas out. We run conferences and summer schools and do lovely things with students. But this is the it's really the coming together of so many different things. There's psychology in this, there's law, there's economics, there's politics. So the students who, on our doctoral training centre in web science, will come from all these areas, have undergraduate degrees in all these areas, and we'll bring them together to try and have a common understanding of how these phenomena emerge, what the main driving forces are. Can we find any fundamentals? Can we, are there fundamental things we can understand about this? Or at least, and one thing about this is we really have to do longitudinal studies. You can't take snapshots and say the web evolves faster than anything we've ever known. It's changed as I speak this sentence. It's you can't observe it in the way we observe other things. It's not a natural system, so we can't. It doesn't follow the laws of biology. They may, we can learn from that. But anyway, so. We think about web science as the theory and practice of social machines, because basically you come up with a technological idea, like the Google guys came up with their mathematical formulae for finding things on the web to meet a social need. I want to find things on the web. And you have to design it in the small and then see if it goes big. And there's so many people out there putting stuff out, and most of the time it doesn't go big. You have to go really big to be successful on the web. We don't understand that piece. And then, of course, when you do go big, things start to go wrong, you haven't designed it right, and you have to start going around the loop again, or new things happen. So we're talking about social machines here. We study shape and structure. The Google guys really exploited the shape and structure of the web. Talked about Wikipedia. It's a new phenomenon of collective intelligence. Emergence of blogging and the blogosphere. The social networks emergence. Citizen science, the crowdsourcing, and people are talking about crowdfunding these days. Because way to raise money is get everybody to give a little bit. Very big business on Twitter. The Galaxy Zoo is an example of getting people who are not theoretical physicists or astronomers to identify galaxies by putting the data out there and training them to do it, and it's been hugely successful. Citizen science movement. The mobile phone, this is all where we're going and where we are, but bringing the rest of the world. It's only 20%, 25% of the world on the internet. It's a lot to go. And they'll all do it on, they'll see the web first on a mobile phone. Have a very different view of it to us on the internet. It's my friend, my student Betty, working in the slums of Nairobi. There's a charity there who give 3G phones to homeless people in there, and he makes jewellery out of bones he gets from the slaughterhouse, and he put pictures of that jewellery on his mobile phone, and he got an order from Germany. Anyway, why does this matter? I'm at the end now. This isn't just about how this technology emerged. This is about actually us as human beings, because this thing has become part of our lives, and is actually all the big challenges we have in the world. We use this technology to help us solve them. So, and it's actually changing. When you think of what's happening with the Arab Spring and the fundamental effects that, the way that technology helps people communicate, it helps the silent majority to find a voice. There are so many things happening. So we think understanding this is very important. And we want to develop the idea of web science collaboratives and observatories that actually capture the information for other people to study and analyse. And I'm going to have to shut up there because I've run out of time, but I hope you've enjoyed that. Thank you very much.